Global warming. Global warming is the increase in the average temperature of the Earth's surface, air, and oceans. Since 1850, that is, since the Second Industrial Revolution, the global average temperature has increased of 0.8 grades Celsius. As the graphic shows, the 2000 to 2010 decade was the warmest decade in recorded human history. The main cause of global warming is the greenhouse effect. The greenhouse effect is the process by which absorption and emission of infrared radiation by the gases trapped in the atmosphere warm our planet. The sun emits solar radiation. Most solar radiation passes through the atmosphere, is absorbed by the Earth's surface, and warms it. Some other solar radiation is reflected by the atmosphere and by the Earth's surface and sent back to the outer space. Some of the absorbed energy is radiated back by the Earth into space in the form of infrared waves. Some infrared radiation passes through the atmosphere, but most of it remains trapped by the greenhouse gases and is re-emitted back to the Earth, thus adding extra warming to our planet. The greenhouse gases, which are responsible for the greenhouse effect and, as a consequence, for global warming, are carbon dioxide, methane, chlorofluorocarbons, ozone, nitrous oxide, and water vapor. These greenhouse gases form a barrier in the atmosphere, absorb more heat, and then this heat radiates back towards the Earth's surface.
Let's begin our discussion by looking at the big one, carbon dioxide, and the critical influence it has on the Earth's climate. What we see here is the Sun's relationship to the Earth and the Earth's atmosphere. The Sun has a surface temperature of about 6,000 degrees Celsius, and it radiates huge amounts of energy down toward the Earth, most of it as visible light or short-wave radiation. The gases that make up our atmosphere, mostly nitrogen and oxygen, but also carbon dioxide, are largely transparent to short-wave radiation. About half of the incoming shortwave gets reflected back to space by the tops of clouds or by light-colored reflective surfaces like ice caps or desert sands. The other half warms the Earth's surface, which then radiates energy back towards space. But here's the rub. That outgoing radiation occurs in a different form called infrared or long-wave radiation. The atmosphere is not transparent to that outgoing infrared energy. Carbon dioxide molecules in fact absorb it, hold on to the energy for a moment, and then re-emit it. Some of that re-emission comes right back down at us as heat. Some is reabsorbed by other greenhouse gas molecules, and some eventually escapes to space. This chain of absorption and re-emission temporarily traps energy in the Earth's atmosphere, and it is this energy that has helped keep the Earth warm. Without this naturally occurring process, the Earth would be considerably cooler everywhere. But if we add more carbon dioxide molecules to the atmosphere, as we've been doing for decades now, these extra molecules increase the interception of outgoing long-wave radiation, thereby retaining additional heat and thus contributing to a more intense warming of the planet. So what has actually been happening to the concentration of CO2 in the Earth's atmosphere? How do we know? Can it be measured? We know this because the added CO2 carries with it chemical fingerprints that very clearly point to the combustion of fossil fuels as the primary contributor of the additional carbon dioxide that is being added to the atmosphere. We use fossil fuels to generate electricity, power our vehicles, heat our homes and offices, and power much of our industrial economy. But what amount of CO2 addition does each of these human activities account for in our atmosphere? Globally, heavy industry, for example, the manufacture of products like cement, steel, and consumer goods, accounts for nearly 1/5 of the CO2 addition. Residential and commercial electricity production accounts for roughly 2/5, and deforestation accounts for another 1/5, as lost forests no longer take up CO2 from the air. The transportation of goods between and across continents and increased automobile use account for most of the remainder. What we have seen from the work of Dr. Keeling and others is that greenhouse gases, especially increased concentrations of carbon dioxide, are contributing to global warming to the extent that global temperature has risen almost 1 degree Celsius over the last 130 years. The burning of fossil fuels on which we are dependent is a main cause. Changing the way we produce and use energy is therefore a major challenge, and one we need to address if we are to limit the amount of warming that human activities are causing.
Since the Industrial Revolution, the concentration of greenhouse gases has increased due to human activity. Carbon dioxide is emitted by factories, power plants, vehicles, and all the human activities in which we burn fossil fuels. The increasing concentration of methane in the atmosphere is due to human activities as well, but a high percentage is emitted by animals, especially cows. Chlorofluorocarbons are emitted by using plastic products, sprays, and refrigerators. These chemical compounds are responsible for the depletion of the ozone layer. Nitrous oxide is increasing in concentration because of its use in agriculture. The addition of greenhouse gases in the atmosphere warms the planet. Because of this extra warming, more water evaporates into the atmosphere. Water vapor itself acts as a greenhouse gas, and the atmosphere warms farther and farther. Most of the rest is due to deforestation. The most important consequences of global warming are extreme weather conditions, for example, floodings and hurricanes, desertification, melting glaciers, rising of sea levels.